So today we have a panel which is composed of Dr. Nomusa Dlamini from the CSIR Advanced Agriculture and Food Cluster. She's a principal scientist. We also have Dr. Tawanda Muzhingi from International Potato Center, SIP. He's a regional scientist and is based in Nairobi. We also have Professor Trust Beta from Food Science Canada, and she's a researcher at the University of Manitoba in Canada. And I'm Ereck Chakauya. I'm the network manager for NEPAD SANBio, which is a program hosted by the CSIR, Center of Excellence on Food and Nutrition for NEPAD. So welcome. Our topic today is very exciting. We are based in the SADC region. The SADC region is more than 350 million people. And there are a number of issues that we grapple with as a region. And nutrition issues are also as critical. We talk of availability of food, accessibility of food, and of course, the utilization, which is the availability of the food in our bodies. And can our bodies mobilize that kind of food to get the nourishment that we need? What I want us to note from the presentation is when we talk of nutrition in the context of the SADC region, what are we talking about? And what is the future of nutrition when we talk of SADC and also the continent? And where is the role of indigenous foods in all this? What's the role of the small grain, like your sorghum and your millets, which traditionally they are grown in the region? And they're also climate smart. So we are looking at the future of sustainability and the environment, but we're also looking at nutrition in the context of production and availability and utilization, as I mentioned. So I will give an opportunity to Dr. Nomusa Dlamini to give a presentation.
My name is Nomusa, and my presentation today is looking at how innovative agro-processing technologies can contribute to improved nutrition and food security using specifically indigenous plants. This is the outline of my presentation. Basically, I'm going to introduce the topic, look at South Africa's plant biodiversity and how CSIR has been involved in historic research on food. We'll look at how this South African biodiversity can contribute to food nutrition and wellness and the product development we've done at CSIR. And of course, we don't work alone. We also work with collaborators. So I'll look at our collaborations. I'll touch on them during the presentation as we move along. Climate change, as we all know, will affect food production and therefore affecting food availability. So what is climate change? It can be drought, which is what is most prevalent in Southern Africa or in Sub-Saharan Africa. And of course, increasingly, this is affecting food availability. Sub-Saharan Africa, where most of Africa lies, is one of the most food insecure regions of the world, where people face challenges of malnutrition, specifically with children. We know that if children are affected, it affects our future generation. Most of the malnutrition is not always visible, because the visible malnutrition is normally stunting or showing signs of starvation. But we have what is called micronutrient deficiency, which is mostly vitamin A, iron deficiency. And this is termed heat and hunger. Of course, this does affect the health of the children. And South African biodiversity and African biodiversity at large can help alleviate this type of malnutrition. Well, I just thought I'll just give an overview of South African plant biodiversity in terms of the indigenous plants that are there. We have over 24,000 plants. That is 10,000 of the world's plants, which is quite huge. And some of our biomass is quite unique, and most of it is still unexplored. but we know that indigenous peoples have been using these for medicines, for food, and nutraceuticals. And modern day, we're also looking at these plants also to harvest or to use as new food ingredients in many aspects, especially food and the fact that we are facing malnutrition. This is just to summarize the history of food research at CSIR. It started in 1963, and of course we can go way back, but this is when it was first recorded, where plants were collected from the field, analyzed, and they were recorded. Several publications were produced, as well as in vivo toxicity. We know that when you have plants and they are not harvested, you can have some toxic components. Some of the plants we commonly consume can also contain toxins, but of course we know how to deal with this. In terms of what we're doing in advanced agriculture and food, we have a group which is called agro-processing, and we have strategic objectives. Basically, the group, which sits within the agro-processing and food cluster, we have skills and expertise in developing innovative food products that can help alleviate nutrition. We use indigenous plants and also sustainably sourced ingredients. We also contribute to establishment of small industries. We know that most of job markets will be created by up-and-coming industries, small industries, or entrepreneurs. So we also contribute to establishment of those so that when they enter the market, they are using natural-based products that have been validated for quality and they're compliant to regional regulations. In terms of South Africa's biodiversity, I think Dr. Chakauya has mentioned that we have indigenous plants that in most cases they are still underutilized. We have sorghum, pearl millet, these are the small grains. They are drought tolerant, they're climate smart, they'll grow with minimum rainfall. And of course, we know that there are other plants as well. We have indigenous legume grains, which are high in protein. We have bambara, which is Vigna subterranea, and we have cowpea, which is Vigna ungulata. They are utilized, and we can use them in various products to develop products. And as I've mentioned, we don't work alone, we collaborate. Our funder is Department of Science and Innovation in South Africa. The Indigenous Knowledge Systems, they fund our research. We also collaborate with Agricultural Research Council, which develops cultivation methods for these plants, because some of them haven't been cultivated at large scale. They are not commercialized. Some of them, people still harvest them from the wild. You wait for the rainy season to harvest them. We also work with the universities. We also work with communities. Communities are very important because at the end of the day, they're the ones who are going to adopt these technologies, adopt these plants for commercialization, for job creation, and also to provide food, for food security. This is just to illustrate the value chain of agro-processing and product development that we follow. Once we identify a plant which has huge potential, even in terms of its nutritional content, in terms of people lacking to have the product or the plant, we develop cultivation methods, and for that, as I mentioned, we work with ARC, which is Agricultural Research Council. They develop these methods. At CSIR, then we come in because we do mostly primary processing and product development. And of course, in some cases, you find that we have to extract active ingredients, especially with nutraceuticals. Nutraceuticals, basically, you have a food plant which has added health benefits. That's when we extract the active ingredients, and then we can formulate. As you can see, we work with communities. We also train them. We learn from them, and we help them adopt technologies. So it's all of a learning process. In terms of developing nutritious products, we have one flagship product that we've developed with the rural school children in mind, which was to help address malnutrition in school children. We know that these children, in most cases, they walk long distances to school, they haven't eaten. So we developed a Nutri-Drink, which uses indigenous crops that are grown by the local people and processed. The CSIR came in terms of training them to process it in a standardized way so that the food product is safe. We tested this NutriDrink in the Eastern Cape, and we found that it did really improve the nutritional status of the children. And the children looked forward to coming to school all the time. So the picture just illustrates the children happy to have this product. It was a pilot project. So the product is still available at CSIR. It's ready to be commercialized and marketed. In terms of some of our other products where we've used indigenous ingredients, we've used leafy vegetables. You're all familiar with amaranthus, with cleome, where we've used them because we know that they are high in phytochemicals, which is your polyphenols, your flavonoids, and also your iron and zinc. We formulated products which we think people will love. We had herbal teas. We all know herbal rooibos from South Africa, but we found that using even other plants that are not rooibos, you can still get a herbal tea with health benefits. We've done muffin mixes. I've mentioned the drink for the school nutrition, which we did with DSI. And we've also canned, like producing convenient food products. Historically, like I've said, CSIR has done some product development. These are some of the products that we've produced, starting with fermented products, which are used as winning foods. Insects, we know insects are creating a hype because of their protein content and because of their sustainable production. We worked with Mopane, which is a local, I would call it a worm, but it's a delicacy. I tell you, there's marula. There's also other whole grain products made from mixed grains, amadumbe, which are made from an indigenous tuber. We've also adopted other technologies in terms of trying to process these into convenient products. We know that some of these crops, they take a long time to cook, so they consume a lot of energy, firewood in the rural areas or even in towns, electricity. So for us to then improve or rather increase the chances of them being adopted as part of our daily diets, we have introduced convenient processing technologies like microwave technology, which will shorten the cooking time, or even extrusion cooking. We've worked with communities, like I've mentioned. We work with universities in one community. We worked with a community in Alice, where the University of Fort Hare is found. The university actually has an agro-processing facility which houses the community. They came in, they were trained, they participated. They actually produced the NutriDrink that was piloted in the Eastern Cape, like as I've mentioned before. And yeah, that's the end of my presentation. Thank you.
Thank you, Nomusa, for the good presentation. I also noted a few things, very interesting things that the CSIR is learning with the communities. It's learning from the communities are also learning from the CSIR, and I think that's a very mutual relationship. I also noted the issue of commercialization or getting the products to the user. We need to create jobs, we need to be healthy, we need to have a strong bioeconomy. So these products definitely will make a difference. So my next presentation will be coming from Dr. Tawanda Muzhingi. As I mentioned, is from SIP, based in Nairobi. Tawanda, the floor is yours.
I was just introducing the organization I work for, the International Potato Center. We're headquartered in Lima, Peru, and we have a presence in Africa, mostly in sub-Saharan Africa. Our regional office is in Nairobi, Kenya, but we have, in Southern Africa, we have presence in Mozambique, in Malawi, and we have activities in South Africa and Zambia. We used to be in Angola, and we also have some presence in Tanzania, which are all SADC countries, not forgetting the work that we also do in Madagascar. So we promote sweet potato and potato agri-food systems to improve livelihoods and nutrition for people in these regions. So to us, potato and sweet potato, in particular sweet potato, I think they are climate, we can call them climate smart crops because of how they can contribute to resilience in the food system to improve nutrition. So we focus more on the orange flesh sweet potato, which is orange in color when you cut it. Most people are familiar with white sweet potato. Some are familiar with the cream ones. Some are familiar with the purple ones. But in Southern Africa, I know since I'm a native, we are used to the white ones and the cream fleshed ones. The orange ones are not so common. But the orange are orange because of beta carotene, the same thing you find in carrots and pumpkins, and the body converts it to vitamin A. And in Southern Africa, vitamin A is one of those big public health challenges that we are trying to solve. And sweet potato is one of the most important crops for human nutrition globally. In sub-Saharan Africa, about 50 million farmers grow it, and it's consumed on a regular basis. So the orange one, as I mentioned, it provides vitamin A for children. Just 125 grams alone can meet the recommended daily allowance for school children. And this is huge. 100 grams is not much. Maybe it's 1 tablespoonful or 1 cup of boiled sweet potato. So what are the challenges we are facing right now? Because of climate change, our cities are growing in Africa. You can see from the chart that in Lagos, for instance, these are the number of people getting into the cities every day. In Johannesburg, you find there are like 21 people being added every hour to the cities. With climate change, more people are going to be moving from the rural areas coming into the cities. And it is anticipated that most of the food will be grown around cities, and most of the food will be consumed in the cities. So how do we prepare ourselves for this changing population dynamics? So I've spoken about the proof of concept studies we did over the years to show that orange fresh sweet potato can provide adequate vitamin A to children and adults. In Southern Africa, sweet potato it's a seasonal crop. It's grown during the rainy season. But we know that in other regions of Africa, like Central Africa, East Africa, they've got 2 growing seasons. So farmers can grow 2 crops and have 2 harvests. So how do we make sweet potato more available to communities in Southern Africa so that they can benefit from the nutrition, and it can also produce a good yield and supply to processors or to value addition opportunities. So we see that it's an opportunity for us to be innovative. We have done some work on storage to improve access using solar. We did some trials in Mozambique to see if farmers can do this in an efficient way on a smaller scale. In addition to the traditional methods of sand pit storage, but you can also do at a large commercial level where you can store tons and tons of sweet potato under climate controlled conditions. In terms of post-harvest research, we can make sweet potato available to people throughout the year by processing. Like Dr. Nomusa is indicated, we can have a flour that can be incorporated into porridges that people can consume. It can be stored over a long period of time. But the challenge is for orange fresh sweet potato, you can lose the nutrition, especially beta carotene. We have now moved to a puree-based application where you steam the sweet potatoes and then they can be eaten directly for children as a porridge or as a paste. They can be incorporated into processed food products like bakery products, fried products, and confer good nutrition to people. And now we have technologies to make it shelf stable, so you don't require refrigeration since it's a very perishable product. and then we can have nutrition being provided to people in the cities who need to get good nutrition, because most of them don't have the land to be growing the crops on a yearly basis. So we have done this with bakeries in sub-Saharan Africa, in Kenya, using the puree, and it has been commercialized. And on a side note, we are also doing the same in South Africa, and we hope in the coming year we'll be launching these products and target the bottom of the pyramid consumers. So there is demand for bakery application because of the over-reliance of wheat. And I'm talking about bakery product because, you know, in Southern Africa, bread is a staple. Most people don't see it that way. And we consume a lot of wheat, and we waste a lot of resources importing wheat. We use a lot of agricultural inputs to produce wheat, which is not sustainable. But we can dedicate half the resources to sweet potato and have a locally grown ingredient that can still allow us to enjoy our bread and also get nutrition out of it. Nigeria, for instance, they saw this and they put a policy in place to make cassava flour mandatory with 10% substitution. We believe with sweet potato puree, we can do a better job and do up to 50% wheat flour substitution, but also providing the vitamin A that people need. And I think we can have the same policies in Southern Africa, in Zimbabwe, Mozambique, Malawi, South Africa, Namibia, and Zambia, where bread consumption is really high among the low-income consumers. So with orange flex sweet potato, we are talking about it's called a biofortified crop because we do breeding as an institution to enhance the resilience of the crop and also increase the micronutrient content by plant breeding. But we tend to focus more on conventional breeding as opposed to transgenic approaches. So the orange flex sweet potato, once biofortified, it can be grown in different regions of the world, in different regions of Southern Africa. So we have a breeding hub for sweet potato in Southern Africa, in Mozambique, that focuses on drought tolerance and drought resistance. So this, we can be assured that the sweet potato that is grown in the region is climate smart. So why is sweet potato climate smart? We know that within a short period of time, within 3 to 4 months, you can have a decent harvest from the crop. It's a short maturing crop, and it produces tons and tons of yield with very little inputs, very little moisture, and very little fertilizer application. Actually, most farmers in Southern, they don't use pesticides, they don't use fertilizers for sweet potato. And it's the second crop after jackfruit in terms of the number of calories produced per hectare globally. So as compared to maize and wheat that we rely on so much, this is a crop that is easy to manage and that can provide lots of food over a short period of time. And with access to irrigation, you can grow it continuously as long as you've got water and high temperatures. So now, because we are facing emergencies like COVID, we are seeing that there's a greater need to incorporate sweet potato into the food systems, both for food security reasons and for providing micronutrients that people need. We are also seeing that in urban areas where people are constrained economically, like now with COVID, there's less incomes and people tend to consume more of the staples and they consume less of animal source foods and fruits and vegetables. So sweet potato is one of the staples that people are going towards. And if we have this staple biofortified and produced by communities, it can help us mitigate the effects of climate change and the effects of pandemic, which I think are also a result of climate change. We can improve the livelihoods of people. So we know that like for other countries, like in Mozambique, for instance, where there's a growing salinity, where some communities are dependent on rice. We know that sweet potato, that varieties that we are breeding can grow under saline conditions. We have tested this work in Bangladesh, where rice fields that were no longer able to sustain rice production were successfully transformed into sweet potato-based production systems. So the loss of agricultural land due to encroachment of the sea, it can be mitigated by adoption of sweet potato production, which also contributes to provision of nutrition and food to communities on a regular basis. And we saw that, I mean, when there are floods, for instance, our work in the Philippines show that when they are flooding, sweet potato is one of the crops that remains on the ground. Other crops are destroyed. So we see that with climate change, there's prolonged droughts, and when the rain comes, it's a lot of rain, and then all the crops are destroyed. But sweet potato is one of the crops that remains and can provide people with food at the moment, and can also help it with the recovery aspect because it's a short cycle crop. So what can we do in Southern Africa? We are seeing, as I mentioned, a rapid urbanization in cities like Johannesburg, Lusaka, Harare, Maputo. So we need to move away from a subsistence farming-based approach to also incorporate an urban consumer-centric approach, because malnutrition issues are really a big problem in our urban areas, and not a lot of attention is being paid. So we need ways to improve the markets of fruits and vegetables, and also root and tuber crops, and understand the dynamics, the consumer dynamics in the informal sector and the whole value chain, and provide technologies to stabilize the prices, to have market approaches in terms of storage and processing as well, so that we have mass dissemination of these nutritious crops. We also want to engage the private sector and make them work with the public sector. We know that if we're going to go to scale with these proven technologies, we cannot do it alone as a public research institute or public development agencies. We need to work with private sector, especially the food industry, because they have the mechanisms and the structures in place to deliver food in an efficient manner to many people than we can with public resources. So we need to work with governments and have policies that can incentivize the private sector to be part of the problem, to solve the problems that we have in Southern Africa, for instance. So what do we need to do? We may want to have improvements in seed supply chains. We want to make sure that suppliers are not affected, or they have access to seed, not just access to seed, but they have access to certified seed. They've got the support, the agronomic support, and they've got also access to markets where they can be assured that whatever they grow at a commercial level would have an uptake from the market. We also need to understand how to incorporate our farmers so that it's a win-win situation. You know, most of the farmers, they complain for lack of access for their commodities. So we want to be able to give them access to markets, and also for governments and donors to help farmers with schemes that can mitigate the risk of overproducing some of the commodities in case of a low demand or other agricultural or climatic catastrophes. So with that, I would like to come to the end of my conclusion, and also thank you for your time. This is a picture of my colleague. We have a nutrition and a food science lab in Nairobi, Kenya, which is called the Food and Nutritional Evaluation Lab. It's a regional center of excellence for the nutrition analysis. We have state-of-the-art equipment. So we support countries in Central Africa, in West Africa, in Southern Africa with their needs to analyze any type of nutritional and food analysis and food safety. And we also give researchers from the regions the platform to be trained and to use our resources to gain knowledge and participate in capacity building. We believe that training the human resource base in Africa will enable us to overcome the challenges of climate change as it affects our food systems and our nutrition security. So if you need to learn more about the work that we do, please feel free to contact me or Dr. Ereck for more details. We can link you up with the available resources we have. Thank you.
Thank you very much, Tawanda. I liked the call to action that we need to put more resources on these climate smart crops, including the sweet potato. You really solved it quite well to me. I like the import substitution. If we put more resources on researching on orange flesh sweet potato or just sweet potato in general, maybe we might not need that much wheat. So, but it also comes to how much resources we put and also how much effort we put on researching on this, and then we can have bread all the time, which is good. So thank you very much. Our next presentation is going to come from Professor Beta.
Talk will touch on the few bulleted items there. When I think of climate smart crops, the first question that comes to my mind is, how are we defining them? So we've had this terminology applied all over the place now that we are facing real challenges with our climate and all the changes that are happening. So I'm going to look at how are they being defined and how we can actually select for climate smart crops. And what we've learned from the first two speakers has been very helpful to talk about these issues. Sorghum and millets, they are my passion because most of my graduate training were on these two sets of crops. Legumes are also being considered as climate smart crops. So I'm going to look at some of those and the global value chain briefly and how we can integrate the climate smart crops, the global value chain, and food security. So my assumption when I hear about climate smart crops are a list of things. The first thing I tend to think of is, well, it has to be high yielding if it's climate smart. So no matter how the climate is changing, this type of crop must be adaptable such that it can still remain high yielding, it can still be disease resistant, and it can be drought tolerant, especially for the Southern African region. So those are agronomic factors that are important for any variety of crop to be adopted by the farmer. But I'm a food scientist, so the next important criteria I would look at if it's a climate smart crop is it nutritious? So nutrition is very important, as Dr. Muzhingi has pointed out, biofortification to increase the vitamin A levels in sweet potatoes. At the same time, people hardly eat for just nutrition. They want the food to be delicious. So it has to be delicious before anyone can buy into that food. So we have to combine nutrition and taste. The obvious parameter is it has to be toxic free. So whatever climate smart crop that we want our farmers to grow must be free of any toxic material. What has been a drawback for some of the crops that are considered climate smart is the issue of processing, which we have to really take seriously. Is this crop processable? Is it easy to convert into various food products. Then lastly, marketability. So it can be as a raw material, it can be following processing some of those products. So then, can we have climate smart crops that can be processed into diverse, tasty, and nutritious food products? So that's a very important criteria to address. So I have on the screen a number of grains from barley, from wheat, from maize, from sorghum. So how do we identify what we call a climate smart crop? What criteria do we want to apply if a crop is going to fall into this group of smart dudes? I guess we can call them smart dudes. So among the cereals, we hardly consider the ones such as wheat, maize, or rice as the climate smart crops, because we want a crop that has some kind of adaptation to adverse climatic conditions, and some sorghum varieties have been found to be in that category. I did come across this interesting paper by Dr. Jiri and his colleagues. The title was Climate Smart Crops for Food and Nutritional Security for Semi-Arid Zones of Zimbabwe. So in that paper, the conclusion was that resource-poor farmers are affected by drought effects due to climate change. Therefore, they can adopt both cereals and legumes climate smart crops in order to create food and nutritional security. So there are two groups of crops, cereals and legumes, that were mentioned in that article. Later on, and very recently, then I saw a review paper on cassava, whereby the conclusion was that cassava can also be called a climate smart crop. And now that I've been listening to Dr. Muzhingi, I know that biofortified sweet potato can also be called a smart crop. LASA India has defined climate smart crops in the context of livelihoods, nutrition, and fragile environments. So this definition includes those crops which are important for the livelihoods and nutrition of poor farmers. They include the tubers, the pulses, the millets. So that does not differ much from what Dr. Jiri and colleagues were advocating in terms of climate smart crops. So pulses are also legumes. So these crops, they tend to be both underutilized and under-researched. As a result, they have not gained the status that we see with a crop like wheat. But they are very important in the sense that they can be used in fragile regions which are subject to frequent droughts, floods, and cyclones. So in selection of climate smart crops, I'm asking that we look at a number of criteria. We are usually blessed with so many genotypes, so many varieties. Dr. Dlamini even mentioned the thousands of indigenous plants which are available just in South Africa. So if we are going to select climate smart crops, we want to look at the genotypes which are available in our African continent. There are several, and I've noticed that there has been tendency to only rely on just a few for our staple foods. So there are a number of untapped resources in terms of just the varieties of crops which are available, which can be used as climate smart crops. The environments also in which they are grown, those are important, and we don't forget the interactions between the genotype and the environment. When we obtain foods that are now consumed by the larger population, we want to look at which fractions are being consumed and which food production methods are being used. Those are all important criteria to consider. In addition to that, we still want to look at post-harvest factors that can reduce food loss. We know that's a big issue, the food losses that are encountered from production to when the food reaches the consumer, and even when the food is with the consumer. So food loss and wastage are important factors which can be added when we are looking at climate smart crops. At the end, what we want is optimal nutrient retention and enhancement in the foods that the population is consuming. So if we look at sorghum and millets as climate smart crops, we know that the composition varies according to the botanical fraction of the grain. So during milling, we can remove the outer layers to produce our refined flour or meal, which is more desirable in terms of the organoleptic properties, the sensory properties. But at the same time, we should be aware of the inequitable distribution of nutrients within those botanical fractions. So we may lose some vital polysaccharides, for example, non-starch polysaccharides. We may lose some protein, some lipids, some vitamins and minerals, and also a number of other phytochemicals. Recent work we did on finger millet, which we collected from Malawi, we could identify so many phytochemicals in the form of phenolic compounds. And this is, for me, an indication that our millets are important food sources, even if they are not yet in the mainstream. They are very beneficial in terms of health promotion. However, those same compounds may also work against the overall acceptability of the foods that are produced from sorghums and millets. So this is work which was done some years back using some of the varieties of sorghum which are grown in Zimbabwe. And producing sorghum meal and then making porridge out of those varieties and comparing with roller milled maize meal showed us that overall acceptance was not anywhere close to that of roller milled maize meal porridge. So there's work to be done in terms of enhancing the organoleptic properties of these sorghums and millets. We like to talk about legumes because we have an abundant resource of these varieties of legumes in the region. So when we combine legumes with cereals, they tend to be very complementary in the sense that legumes are a very good source of protein, and the amino acid profile of legumes will complement that of our staple cereal grains. As a result, more work needs to be done in this area in terms of promoting our legumes. And Dr. Dlamini mentioned the bambara nut, which is one example of an important legume. Now, when we look at these tubers, Dr. Muzhingi mentioned the bio-fortified orange fleshed sweet potato. That's one type of tuber which is going to be important, especially to address vitamin A deficiencies. But there are several tubers that can be used for supply of micronutrients as well. And at this point, they are still under-researched. The problem that we have with legumes, not legumes, but with the tubers compared to legumes is that they tend to be very high in moisture content. So tubers have a very high water activity. So that water activity will work against a long-term storage of these tubers, unlike when we are looking at legumes. So we need to look at processing to produce shelf-stable foods. So what lessons can we learn from wheat, which has dominated the food world? So we know that with the wheat, you can produce so many varieties of foods. And even in Southern Africa, the region where I'm originally from, you can see that people are drawn to wheat products in the form of breads, in the form of pastas. However, there is opportunity to actually use some of our indigenous crops, which we call climate smart crops, to enhance some of these products and reduce the use of wheat flour. So we can still produce the same products, but substituting with some of our indigenous crops. So let's talk about food products and climate smart crops, because the area of processing has been lagging behind when it comes to climate smart crops. So we still need support systems for both pre-harvest and post-harvest technologies. For example, we need more resources towards agronomic and breeding programs for these climate smart crops so that we identify which ones are the most important for the different regions of the continent. We also want to look at storage and shelf life of these climate smart crops. And what Dr. Muzhingi is doing will help if we are producing flour or purees of the tubers. We also want to be in food product development, because most of these underutilized crops, they don't have many products to talk about or even to entice farmers to keep growing them. And in general, we assume that they are very safe in terms of any toxic material. The research has to be done in terms of looking at the structure of these crops versus the functionality that can be derived from them. So my main area has been more to look at the health benefits in terms of health promoting components. And there is a very big opportunity here, because if we are looking at climate smart crops versus animal food sources, there is no comparison. We can be fed mostly from crops compared to animal sources. So public and private partnerships in research and development of these climate smart crops are very vital to their promotion. This is an example of unit operations and key factors that are influencing the final product quality. So this was a discussion on cereal raw materials, what they undergo before they can get to the consumer. We can use all these processes, and through institutions like CSIR, what Dr. Dlamini is doing, we can produce more food products from our own resources using a combination of these techniques. At the end, we want to be able to provide not only healthful foods, but acceptable foods in terms of organoleptic properties. So when I was thinking of the global value chain and our climate smart crops, we cannot talk about the global value chain without looking at the people and the activities involved in the production of those crops. We cannot talk about the global value chain without talking about supply and distribution, not just regionally, is restricting to our continent, but also globally. We cannot talk about the global value chain without looking at other post-harvest processes for these climate smart crops. So the question is, who is involved in the production? Who are the main players? And when we look at gender, and especially smallholder farmers, what is the role of women in these global value chains? There are sustainability issues that are very important when we are talking about climate smart crops. The UN Sustainable Development Goals and the 17 Goal Blueprint are very, very useful, but I don't think there are checks and balances in how these are being implemented. So there are several opportunities I see for integrating the climate smart crops into the global value chain for food security. A connection is being established between diet, health, and environmental sustainability. So we need to make sure that we exploit that nexus between diet, health, and environmental sustainability. So we can also see an opportunity then to use climate smart crops found in Africa to address healthy issues. We can identify those which are already loaded with the micronutrients that are deficient in several regions, but at the same time, we can use the biofortification approach, especially where the deficiency is severe, for example, vitamin A. There is a growing demand for protein in Africa and beyond, and the role of plant proteins in climate smart crops is unchallenged compared to animal protein because it takes a lot more. It's not environmentally friendly to use more animal protein compared to plant proteins. So we can use these smart crops for addressing global food and nutritional security, especially if we can identify those with the essential nutrients such as those which are high in iron and zinc, and also those which are high in some of the vitamins which are of concern. So in conclusion, I would say the climate smart crops are very vital to improving food security, and they should include the cereals, the legumes, and the tubers. That their selection is important if we are going to address food and nutritional security in different parts of Africa. However, we do need to integrate the climate smart crops with the global value chain so that the beneficiaries are smallholder farmers and they can have enhanced food security. To be able to do that, we need partnerships between public and private sectors, and Dr. Muzhingi has already alluded to that those partnerships are very essential to achieve such an integration. but the benefits are quite enormous given the nexus between diet, health, and environmental sustainability. Thank you.
Thank you, Prof. Beta, for raising some important points. I liked the conclusion also on the diet, health, and sustainability, environmental sustainability nexus. It's very important, but also the the aspect that food has to be delicious also. I thought that was quite that was quite good. Then because that brings in all the processing, the storability, and all the other factors, and that's where the research comes in, and the partnerships, private public partnerships, they become quite important, which is why also even in these discussions we try to build the sort of global value chains that we want. We need to have the right partnerships, but at the end of the day it's about the value. Do we know, how much effort are we putting understanding the value of these climate smart crops? Where is the value, and who is benefiting from that value, if there are any benefit? Because as of now, it seems like we are still trying to establish that. So we'll ask for questions. My panelists will be available to answer some questions before we can conclude. Thank you.